This module, we're going to take a look at how we manage virtual machine disks for virtual machines that are running on Azure. To begin, let's look at the overlying architecture of storage of disks for virtual machines in Azure. Now, there are three things you've got to think about in here. We have our operating system disk. The operating system disk is the C drive, and it's kind of a special disk. You don't have as much control over it. Every single virtual machine has a temporary disk, a D drive. This is a drive that you shouldn't store persistent files on because if you shut down the virtual machine, the contents are lost. It's meant to be a temporary storage point. For example, a page file could go there. It's, for example, you could put short-term files while you're doing copying. You could put just things you're working on in that individual session that, once the VM powers down, it's okay that they're deleted. And then drive F and upwards is our data disks. So if this, for example, is going to be a SQL Server database, the SQL Server files would go on drive F and above. And you can have as many drives as the size of the virtual machine you've selected allows you to have. Remember, the type of virtual machine you pick, the size of the virtual machine, dictates how many additional data disks you can have. Now, these data disks, once they're added, you can begin to leverage some of the storage capabilities of Windows Server to create some interesting things. For example, I could have multiple data disks on here. And I could then take those data disks and combine them into a Windows storage space, thereby giving me better throughput, better performance, and greater storage. Behind the scenes, all data disks are VHD files stored in a blob, in a container, in a storage account. So what are some of the tasks that we would typically do? Well, we can attach operating system disks. We can add or remove a data disk. And we can modify disks to make them bigger or change the caching behavior of the disk. And as we recommended, within, if these disks are attached to a Windows Server virtual machine, you can leverage storage spaces within Windows Server to combine multiple data disks into a single, larger, faster, more high-performance volume. How do we perform these tasks? The Azure portal, both the classic and the new portal, support basic disk manipulation. Things like adding disks, creating disks, and removing disks. So you simply go to the properties of the virtual machine, go to the properties of the storage, and there are sections that allow you to add, remove, and edit disks. You can also do this via PowerShell, either in the Service Manager model or the Resource Manager model. A couple of tips. Number one, and we mentioned some of these earlier, the size of the VM determines the number of disks. If you want to use premium high-performance storage, you must have a DS or GS series virtual machine. For new disks, the operation of attaching the disk also creates it. So you don't need to create an empty disk and then attach it. If you attach a disk, it will actually create the empty disk for you. All disks are VHD files, not VHDX. So if you're uploading, you've got to convert to VHD first. And then if you're going to attach it, it's already got to be in the storage account. So you would use a tool, for example, like the Azure Storage Explorer, which is a free download from Microsoft, to connect to your storage account, transfer your VHD file in. And so I can, for example, explore my storage accounts, transfer my VHD files in, and then attach them directly to a virtual machine. So with that in mind, let's take a look at some of these tasks in action. Let's take a look at the process for attaching VHD files, both brand new empty VHD files and as well files we may have uploaded through tools such as Azure Storage Explorer that contain files you want to transfer from our on-premises data center location up to an Azure virtual machine. So to begin, I've got a web server virtual machine. This is just a VM running Windows Server 2012 R2. And I'm going to navigate down on its blade to its disks settings. And so we now have got our OS disk and we have our data disks. What we're going to do is just use the add new and attach existing options to add some data disks to this virtual machine. So I'm going to click attach new. It's going to auto-generate a disk name. We'll just take the default. Ask me for a size. We'll do a 512 gig SSD. Tells me what the performance metrics are, so the IOPS limit and the estimated throughput of 150 megabit per second. The actual file storage location. And then if I want to do any host caching. So we're going to click OK. And it's going to start a job to attach that new virtual hard disk. Now for the next one, I've already uploaded, and if I take a quick look at my Azure Storage Explorer tool here, you can see I've already uploaded a VHD called Extra Files. We're going to go ahead and actually attach that VHD to this virtual machine. So we'll click Attach Existing, and then select the VHD file that we want to upload. It'll find all my storage accounts, and I want to use this web server VHD storage account. My VHD's container, so I'm essentially navigating what is the equivalent of the file system. Extrafiles.vhd and click Select. Click OK, and it'll now in the background start the job to attach that existing virtual machine. So once this job finishes, we'll log on to our virtual machine and verify the disks are actually there. So that job's now complete, and we can see we've got 2 extra VHDs attached, one empty and one with some files that we uploaded from our local data center. So for new Azure customers that are looking for ways to migrate their existing workloads to Azure, in many cases you might have some pretty significant storage requirements and some pretty large VHD files on your existing infrastructure that you need to move into Azure. So what are the options to do this? Well, we have 2 PowerShell commandlets. We have Add Azure VHD and Save Azure VHD. Both of these commandlets will allow you to upload, an existing VHD file to your Azure subscription. They're very simple, very easy to use, and they both support multi-threading, so you can actually get the maximum throughput out of your connection. There's also another option. The other option is you can, the old-fashioned sneaker net, you can have someone carry the file. So you can copy data to a hard drive, you can ship it to Microsoft, they will physically plug it into a server and copy the file to your storage account. Now in many cases, if you're dealing with many terabytes of data, this is really the only viable option. Uploading hundreds or terabytes or petabytes of data, it's just not feasible over an internet connection unless you've got a pretty good internet connection. So shipping might be the only option. Likewise, if you have a lot of data in your subscription, Microsoft can copy it to a hard drive you provide them and then ship it back to you. Now, again, this is not free, but it's a very viable option, especially if you have a large quantity of data. So let's take a look at an example of using the PowerShell version. We're not going to demo shipping something, but let's take a look at the PowerShell version of moving a file into Azure. Let's look at 2 methods of uploading a VHD file to Azure. The first one is using a storage tool. Now there's a number of storage tools available on the market today. The one that I'm using here is the Microsoft Azure Storage Explorer, which you can download from Microsoft's website, and it does a pretty good job of doing most storage activities. One of the things it makes particularly easy is uploading local VHD files to an Azure storage container. So what I've got here is just a storage account. This is just a regular vanilla storage account. I'm going to make a container that's going to contain a number of virtual machines. So we're going to click on Create a Blob Container, and we're going to type VHD. And so that's going to create for us a new storage container. It's got to be in lowercase. That was the little area you saw right there. I have a habit of putting things in capital letters. So I've now got a storage container for VHD. And what I can do is come in here and just upload a VHD file. Browse to my local file system. Click the name of the file I want to upload. Click Upload, and you can see down here in the progress area, away it goes. Now I'm going to go ahead and cancel this one and upload this file using PowerShell, which is the second method. So I'm already logged on to my Azure PowerShell subscription. And what we're going to do is go ahead and actually upload that VHD file via PowerShell. Now to do this, add Azure RM VHD, the resource group name, the local file, the destination file. Now, a little trick you can use with something like Azure Storage Explorer is you can come down to the VHD container that we created, and in the properties you can actually get the URL that the uploader is going to need. So we're just going to highlight this and press Control-C on the keyboard to copy it back to PowerShell, and we can paste that right in, and then just complete it with the file path. We'll increase our uploader threads to 10 so we get a little better performance and get some more detailed output with verbose. And there we have it. It's now going to begin. Oh. Well, it would begin if I hadn't already uploaded it to make sure the command worked. So let's just come back here and delete the file. Go back to PowerShell. And away we go. And so this upload is going to do two processes. It's going to run a hash on the file that it's going to use to validate the upload is complete, and then actually go ahead and complete the upload. Now, for this particular example, and again, I'll let you in on a little secret that I did test this beforehand, takes about 5 minutes to do the hash and about 16 seconds to do the upload. Now in this module, we're going to look at some of the tools and some of the techniques for managing virtual machines that are running in Azure. Now, the first thing to look at is, what are all the options that are available? Well, regardless of whether it's Windows or Linux, you have three choices. You have something called VM Agent Extensions, which we'll talk about in a second. You have the Azure Cross-Platform Client, which we're going to look at in this section, and then Azure PowerShell that we've looked at a couple of times over this series of courses. For Windows, you have RDP. Remember, we had talked about the fact that there's no console access. If you want to gain access to the Windows desktop experience, you have RDP. And for Linux, it exposes a Linux SSH endpoint, either using a password or an RSA key authentication. So what are VM extensions? VM extensions are pieces of functionality that you can add to a virtual machine that serve a very specific and very dedicated purpose. For example, there are VM extensions that integrate with cloud backup providers. There are VM extensions that provide desired state configuration or antivirus scanning. So think of these as small software packages that you can choose to add to any VM image at any time, either during deployment or after deployment, to add an additional capability to that virtual machine to somehow extend its functionality. In many cases, you can automate extensions. For example, if you have an antivirus extension, you can then, from PowerShell or the CLI, have Azure tell the virtual machine to perform a scan. You don't necessarily need to connect to the virtual machine instance. You can instruct Azure to tell the virtual machine to invoke the extension. One of the more useful extensions is something called the Custom VM Script Agent extension. Now, what this does is it allows you to have scripts outside the virtual machine run inside a VM. So to give you an example, and this is useful both Linux and Windows, it could be a PowerShell script, if it's Linux, a Perl or a Bash shell script. You can store this on, for example, a GitHub account or an Azure storage account, or any place that's accessible on the internet or within a storage account within your subscription. And maybe this represents the instructions to install or configure your VM in a particular way. With the script agent extension, you can tell Azure to simply, here's the URL for a script, here's the virtual machine, go run this script in this VM. And Azure will take the script, load it in the virtual machine, execute it, and give you back the results. And so it becomes a very useful way of configuring VMs. For example, if you want to troubleshoot something, maybe the network is broken, maybe you can no longer RDP and you want to go in and reset or change a configuration, the script extension gives you a way to go around some of the basic functionality, insert the script, run it, and perform a series of tasks. So that's one example. There's others, but let's take a general look at now how we enable extensions within virtual machines. So now let's take a look at one of the more useful, or say a couple of the more useful extensions. The first one, and this is, if you're a Windows administrator coming from an on-premise administration scenario, you've likely come across something called desired state configuration. Desired state configuration allows you to, in a declarative way, describe how you want a Windows system to be configured. So much like an ARM template allows you to describe what you want in an Azure resource group and then have Azure worry about the details of the implementation, desired state configuration allows you to describe the state of a Windows or Linux system, and it will worry about getting that state implemented. For example, in Azure you can say with an ARM template, I would like a storage account. It will create it for you if it's missing. With DSC in Windows, you can say, this service or this daemon in Linux must always be running and must auto start. And regardless of its current state, when you apply that configuration, if the service is incorrectly configured, DSC will fix it. In Linux, it will do the exact same thing. And so it's become a standard way for Windows and Linux administrators to make sure that their systems are configured correctly so the applications that they have on them will run. It removes a lot of steps of troubleshooting because you no longer have to worry about, well, what's wrong? We simply say, well, something's broken. I don't care what's wrong. Here's the correct configuration. Apply this, and that should fix it. So within Azure, there is an extension that allows you to leverage your investment in desired state configuration and take those DSC files and apply them to both Windows and Linux virtual machines in Azure. The DSC files can be stored within an Azure storage account. And when you, for example, provision a new virtual machine, perhaps you want that to be a web server, you can have a desired state configuration file that says, make sure what the web server roles and services and roles and features are enabled. Deploy the new VM with an ARM template, apply the DSC file through the extension, and voila, you have a web server in Azure. So again, as a concept, it's pretty straightforward. The implementation requires obviously knowledge of how to work with DSC, but it allows you to seamlessly take your desired state configuration investments from on-premise and leverage them within Azure. Now, because Microsoft, but because a lot of folks that are using cloud services are coming from a Linux world more so than a Windows world, a lot of the popular tools for Linux are also supported on Azure. One of them is a tool called Chef. Chef is another, similar to DSC, is a configuration management solution that allows you to define the configuration of your systems. Now, this was very popular in the Linux application server environment, but is also available on Windows. So again, if you have an investment in Chef as a configuration management tool, there is an extension that you can put in your Windows virtual machines and your Linux virtual machines to allow them to seamlessly integrate into a Chef environment and take those configuration settings. Also, there's Puppet. Puppet, similar to Chef, is a configuration management system. Now, it works a little bit differently than Chef. The use cases are slightly different. Chef allows you to go in and build configuration files. Puppet works a little more like DSC in that you create a desired state. It will enforce that configuration more so than just apply it. And it's a complete client-server model where you can have a Puppet master server with all your configuration files, and then all your different application servers can pull their configuration down. Again, conceptually, DSC, Puppet, they work kind of the same way. Puppet originated in the Linux world, DSC originated in a Windows world, and you can use Puppet to apply DSC files. Now, there's a lot of alphabet soup. There's a lot of different options. The point being that you have many, many different ways, depending on what you're comfortable with, to apply configuration and manage configuration within virtual machines that are running in Azure. The next piece, and this is probably one of my favorites, is the command line interface. Now, we've talked about PowerShell. PowerShell is not PowerShell up until a couple of days ago was not available on Linux or Mac. So what if you worked on a Linux or a Mac workstation, or you were just familiar with Linux shell scripting, in either a true Linux world or in a Mac console world, and you wanted to leverage those skills to build solutions on Azure. Well, that's where the Azure command line interface comes in, what's called the cross-platform command line interface. It's a command line interface that supports the majority of what you can do in PowerShell, but it operates just like a command shell. You type commands, it produces text output. The great thing about the command line interface is you can install it on Mac, on Linux, or on Windows, and if you write a script in the command line interface, that exact same script, letter for letter, will work on Windows, on Linux, and on Mac. So it doesn't matter what you're comfortable with, you've got an option for doing automation and configuration from a command line within all three of those environments without changing a thing as you move between them. So let's take a look at how these commands are structured. Within the command line interface, it's a very simple topic, noun, verb setup. So for example, we have VM show, which will list all the virtual machines. VM endpoint, we can start it. And as you start to work through, you'll see that it's very simple and it's very discoverable, much like PowerShell is. Any command, you can put -- help on the end. It'll show you all the available options for the command. Very simple. So rather than talk about it, let's kind of take a look at it and sort of dig in and explore this cross-platform command line interface a little bit. Let's take a look at using the Azure cross-platform command line tools. Now, the great thing about these tools is they're the same, whether it's on Windows, Linux, or Mac. So if you're an administrator and you want to do automation, but you've got multiple operating systems where you're going to work from, this provides you a great option to do virtually everything you do in Azure that you would normally do with PowerShell or with the portal. Tasks like creating objects, deploying resource templates, creating resource templates as templates, lots of different things you can do in there. So to get started, you install it using the Web Platform Installer. It's just one of the options that you can add. Now, to use it, I'm actually going to use the Bash shell that's installed on Windows 10. So this gives me kind of a true, Linux-like experience, given the fact that this is, a true Bash shell, not an emulator. And so to get started, I'm going to go ahead and log in. Now, the login process is a little bit different in the sense that you've now got to go to a browser to complete the logon process. So we'll just open a browser instance and go to aka.ms/device login. And we'll just complete the logon process by pasting in this code they give us in the console. Identifies that this comes from the cross-platform command line. And we'll go ahead and actually just complete the logon. And once this is done, the console gets a signal that the logon's completed, and we can see that we're now ready to go. We can see we're connected to our subscriptions. And it's actually Azure account list, not subscription list. Now, the thing to note here is that all the commands follow a very similar syntax. It's just an individual keyword, space, keyword, and as you work through, you have Azure, the item you want to work on, the account, and then the action you want to take list, along with any parameters that might actually pop up or might be required. So to give you an example of that, we're going to do something real simple, which is just create a basic resource group. So to do this, we'll kind of walk through the process of understanding the command structure and also how we use the help to navigate the command structure. So if I type Azure help, it's going to list all the different commands and objects that I can work on. And if I scroll up a little bit through this, kind of towards the top, let's go a little bit quicker. You can see that we've got an option for group. And this allows us to command, these are commands that help us manage resource groups. So what can we do with a resource group? Type Azure group help. This will give us help specific to what we can do with a resource group. If I scroll up a little bit, you can see that we can create a resource group. And to create a resource group requires two options, which are name and location. So we'll type Azure group create help. So we know it needs a name and a location. If we look at our options, we can see that N gives us name, L gives us location. The name of the resource group, and then the location where it's actually going to be created. So this is the Azure region. In our case, we're going to use East US. So we'll type Azure group create name. Call this one CLI group because it was created with the client tools. Location, East US. And that goes into our subscription and creates that resource group. And we can now see if it's there using list. And we can see we've now got two resource groups. There's one I just created called CLI group, and there's another one called Travel app that I created earlier. Another kind of interesting thing we can do is we can take a resource group and export that resource group as an ARM template and modify that template and then create maybe a second resource group, which is a modified version. So you can begin to see how we can take this unified client and then as we move from platform to platform, begin to fully automate our Azure implementation. So for that particular example, we'll do something like Azure group, and we'll use the export command, and we'll export the Travel app resource group. That's going to download the entire contents of that resource group, which contains storage, which contains virtual machines and networks and all sorts of settings as an ARM template that we can now bring into our favorite editor and modify. And so we can see if we look in Windows Explorer, here's the JSON template that it just downloaded. And if I open that in Visual Studio or any text editor, here's the template right here. And we can then take this template as the basis for an additional deployment. One additional thing that I want to show you real quick is if we go log on to our portal. So let's go to portal.azure.com. This client becomes part of the automation that Azure produces automatically for any object that you create. So if the unified client is your preferred method of scripting against Azure, any object that you create, you can get the script that's appropriate for the cross-platform client just by getting it straight out of the portal. So if I click on my resource groups, and I go to my Travel app, and let's say that I want to see the unified client script to actually create this resource group, I can simply come over here to the automation script area in the settings. And then in addition to all the normal automation options for an ARM template for Windows PowerShell or for .NET, there's a CLI option as well that will actually recreate this resource group. Now the key to this, this is a pretty long script. The key is kind of this one line right here, which is the same thing we typed in the client. Everything else is just structure that allows us to make sure, that this script runs successfully. If the object is already there, it doesn't attempt to recreate it and so forth. But at its core is that same Azure group create. So if you're creating objects within the portal and you want to turn around and automate those within the client, you can simply look at the automation script and then kind of pick out those individual commands that you want to help you figure out how to learn that automation. The final topic of this course is how we monitor an Azure virtual machine. Now, before we get into this, let's kind of think about scale for a second. If you're deploying, a very large application, many virtual machines, complex, many layers, many tiers, you obviously want to make an investment in an enterprise level monitoring system such as Microsoft EMS or Operations Manager or one of these large-scale distributed application monitoring systems. However, if you just have a couple of virtual machines, or you have a particular virtual machine and you want basic monitoring, Azure provides that for you directly in the portal with no additional third-party or software installation whatsoever. It's a simple checkbox. You enable monitoring. If you enable monitoring, this is what happens. A VM extension is installed. We talked about those. This is another one of the VM extensions. Either Windows or Linux, doesn't matter. It will track the boot sequence. Because you don't have console access, you can't see the boot sequence. This will capture the boot sequence and allow you to view it. It's also going to contain diagnostics data, things like the event logs, things like the boot logs from Linux, and store them in a separate storage account within your Azure subscription. So when you enable this, it's going to make a dedicated storage account. It's going to create some entries in that storage account for all the monitoring and diagnostics information. You can then set alerts to look for example, certain conditions like a high CPU, certain things like a particular event log entry, so you can get a notification that that particular entry or that particular item has occurred, and you can now go respond to it. So with this, you get a pretty robust monitoring system. Granted, for an individual VM, you would enable this per VM, and every VM is going to have a different set of rules, but you don't need any third-party applications. You don't need to install or configure anything. You simply turn on monitoring, and you get a pretty robust set of monitoring tools for that individual VM. Certainly recommended that this be turned on for any VM you care about. So that's a quick look at how we monitor a virtual machine. Let's go in and kind of fire it up and see what it looks like. Let's take a look at the basic virtual machine monitoring that's available in Windows Azure. Now, I've already deployed a virtual machine and I've enabled monitoring. We'll get to how to do that in just a couple of minutes. So this machine, monitored server, just has basic monitoring enabled, and you can see that it created a storage account for all the monitoring information. Now, if we go look in that storage account, and we'll just open up our Azure Storage Explorer. And we go ahead and just connect to our storage account, you'll see the basics of what is included with that monitoring storage account. So if I go down here and I find it, I have monitoring east diags. If I expand that, we'll see there's a blob container which contains what is essentially a current screenshot of the state of the virtual machine. So if you ever wanted to look at the console and see, what's on the console right now, is it booted or is there maybe a blue screen? This is a current snapshot of the console. It then also has a series of tables it creates that contains diagnostics information. Now, most of this is not human readable. It's read through the portal in the way, and they surface this information in the portal. But you can get some, you can get some basic things by looking in here. For example, here we've got some event log entries. So it pulled these event log entries out of the virtual machine and surfaced them in the Azure portal. Now you can start using this information to do different things. For example, if I go to this monitored server, you can see it keeps a live graph of the current CPU utilization on the server. And this just gives you a quick snapshot of, is this machine busy right now or is it idle? You can then also create alerts based on this monitoring information. For example, if you wanted to take an action if the CPU utilization got too high, you can create an alert on the CPU. And we'll just do this real quick. We'll call this one high CPU. And we just want to be emailed. So if the condition, we're just going to select our metric, and we'll now see all the metrics that it tracks. And we'll do CPU percentage guest OS greater than, let's do 75%. Over the last 10 minutes, let's email the administrator. Now there's other things we can do, such as integrate into larger scale monitoring and alert systems or take automation actions. We're not going to worry about that right now. We're just doing a simple create an alert. If it goes too high on the CPU, send us an email and let us know that this server is busy. Now we mentioned that bitmap. If I come over to my settings for this monitored server and I look at my boot diagnostics, this will show us a copy of that bitmap of what does the console of that server look like right now. And under our settings, we can control whether or not that happens by checking this boot diagnostics option. We can also look at, what events, we mentioned the event logs, do we want to capture. For example, in the case of the system logs, we only collect error, but we could also collect warning information or anything else. Now what this will do, if you choose warning, it'll take warning, error, and critical. So it takes from the level you pick all the way to the most severe level. So how do I deploy a virtual machine with monitoring enabled? It's really quite simple. I'm going to add a second virtual machine to this resource group. And this works, by the way, for both Linux and Windows. We're just going to choose a Windows VM to keep things simple. And as you begin to deploy the virtual machine, so we're going to put a name in. And you've seen me do this a million times so far, but it's still just a basic process. It's going to keep some defaults. And we're just trying to get down to this number 3 step, the settings step, so we can show you where to enable the monitoring. Choose our virtual machine size. We'll choose just a small size. And so here in the optional settings, we have a section for monitoring. It's enabled by default. We can choose to disable it if we don't want that overhead. Having the monitoring does incur charges on the storage account because it is storage account transactions. Or we can simply enable it and then choose a storage account. It's going to create a storage account by default, but we could certainly choose a different storage account if we wanted specific storage accounts, maybe in a specific subscription or specific resource group. Click OK, and that's going to go ahead and enable monitoring as this virtual machine is started.